This is a video about sinking funds. In this video, we're going to define some terms, develop the formulas and thinking for sinking funds, and solve some sinking fund scenarios. In this video, we're going to be talking about sinking funds, and sinking funds are just ways to save for a spending goal. The idea is if we deposit money on a regular basis into an account that earns interest where the method of compounding matches the frequency of deposits, then this is a sinking fund. So this is really important here. We need the method of compounding has to match the frequency of deposits. So if we're compounding monthly, we're depositing money each month. If we're compounding quarterly, we're depositing money each quarter. Saving for retirement is one way we use sinking funds and annuities. Annuities are just a type of sinking fund. And 401k accounts, these are also, we can think of these as sinking funds. In this video, we're going to develop ways to answer questions about the process of accumulating money. The biggest difference that we're going to see between this new topic of sinking funds and the topics that we previously looked at, simple interest and compound interest, is that with both that simple and compound interest, we're only depositing money once. Sometimes we call this a lump sum. Whereas with a sinking fund, we have a series of payments. And again, the frequency of payments has to match the frequency of compounding. Let's look at a scenario. We decide to deposit $500 into an account each month. The account earns 4% per year compounded monthly, and we're depositing money at the end of every month for 6 months. We want to know how much do we have in the account after 6 months. So when we first open the account, we don't have any money in there. We deposit it at the end of the first month. So this is month 0, month 1, month 2, month 3, 4, 5, and 6. And each time we're depositing $500 at the end of every month. So when we think about this $500 that we deposit at the end of the first month, it earns interest for 1, 2, 3, 4, 5 months. When I look at this $500, this earns interest for 1, 2, 3, 4 months. So this column here tells us how much interest each individual $500 earns. Now we can find the future value of each $500 deposit by using our compound interest formula. So we've got 500, we've got 1 plus 0.04 divided by 12 to the 12 times 5 over 12. Now notice here this 12 times 5 over 12, that just ends up giving us 5. So I found the future value of each $500 deposit. Our total value is going to be the amount in the account, which would be the total of all of these $500 deposits. So we can see that the total is going to be $3,025.11. Now, one thing to think about is we deposited $500 each month for 6 months. So our deposits, we had 6 times 500. We deposited $3,000. And so we can tell from this that this $25.11, that's the amount that we ended up earning in interest. Now this process that we used here would be a good process to use if we've just got a few deposits, or if we have a large number of deposits and we're using some spreadsheet like Excel, we could calculate this pretty easily. But if we're trying to do this by hand or just using a regular calculator, this is not a feasible method when you have a lot of deposits. So we need to come up with a different one. Through some algebraic manipulation, when we add up that series of deposits, we find that the value in our account can be given by this formula here. If I wanted to solve this formula for the payment, I would get this second formula. They're the same formula, it's just one solved for future value, one solved for payment. Now, a lot of these terms and variables are the same as they were before, but there's a few differences. FV is future value, just like before. PV is present value, just like before. T is time in years, just like before. Annual interest rate, and M, those are all the same. The I here that's in our formulas, this is our interest rate per period. So this is our R divided by our M. And then we also see this variable N, and that N is our M times T. This is the total number of payments or the total number of deposits that we've made, and it's the total number of compounding periods. So let's look at that same problem that we just did with the $500 sequence of $500 deposits and find the future value using our formula instead of using the method that we used. We need to figure out what these values are in our formula. So our payment, this was our $500. This is the amount that we're depositing each month. Remember, our I is our R divided by M, and our interest rate was 4%, and we were compounding monthly, so our R divided by M is 0.04 divided by 12. Our goal is our future value. So if I were going to use my formula to find the future value, I would have 500, I would have 1 plus 0.04 divided by 12 to the, okay, now we didn't calculate N. Remember, our N is our M times T. Our M was 12, and our time was 6 months, and time is always in years, so our time is going to be this 1/2. 12 times 1/2 gives us 6. That's the same number as the number of $500 deposits that we put in. This is going to be raised to the 6, and then we're going to have subtract 1 over 0.04 divided by 12. Now, entering this into the calculator is a little bit challenging, so what we need to do whenever we have more than one thing in the numerator or denominator, we want to have parentheses around it. So when I go to enter this into the calculator, I need to have parentheses here, I need to have parentheses here, I also need parentheses here and a parentheses here. When I type this into my calculator, this is what it needs to look like. You should get the future value is $3,025.111389, which we would round to the $3,025.11. We also have another way that we can solve for that future value using a tool on the called the TVM Solver, or Time Value of Money Solver, on the TI-83 or 84. Also available on other versions of the TI, but not all the versions of the TI. Many other calculators have something similar, so if you have a Casio, I would recommend that you Google or look on YouTube and you'll find instructions. To do this, the first thing we're going to do is we're going to press this Apps key, then we're going to choose the Finance option, and finally we're going to choose TVM Solver. The TVM Solver uses slightly different variables, so let's talk about what they mean. The first thing in that TVM Solver screen is the N. The N is M times T. The I is the annual percentage rate. So it's like what we use for our R. But the other thing that's important here is that this annual percentage rate is given as a percentage, not as a decimal. So if you have 4%, you need to input 4. Present value is same thing as we had before. Payment is still that 500. Future value is what we're looking for. Payments per year and compounding periods per year, these are both your M. And you're going to find if you input one of these, so like if you input payments per year, that number is going to be copied down into the compounding per year. So if we were going to do this problem that we've been working on, the $500 deposits for 6 months, we would need to input the following values into our TVM Solver. So our N is 6 because we had 6 deposits. My interest rate, annual interest rate was 4%, so we're going to put 4. My present value is 0. Now notice one thing that's different here is I put my payment is negative 500. You can leave it as positive 500, but what's going to happen is one of the payment or the future value, one of these is going to be negative. Our payments per year and our compounding per year is going to be 12. So this is the style of compounding and the frequency of payments or deposits. It is not the number of actual payments. The number of actual payments is the N. So once we get all our values correct, we're going to come over here and we're going to put our cursor on the future value, and then we're going to press the second button and the enter button. This accesses the solve feature in our calculator. When you do, you're going to get that $3,025. We would round to 11 cents. So let's see it on the TVM solver. Let's go back to the start and talk about our big goal here. So I'm thinking about a retirement scenario, but we could also be thinking about saving for any other type of goal. When we're doing this, what we just did was we did a problem on what's called the accumulation side. So we're building up a big pile of money here. So we've got a big pile of money. And in the last scenario, what we were doing is we were taking $500 deposits and sticking it on our pile. Now the pile's going to grow from our series of deposits, but it's also going to grow from interest being earned. Typically, not always, but frequently, when we're doing these situations, we start out with nothing, so our present value is 0, and then our goal is to figure out what that future value is. We also have a withdrawal side, and we're going to focus on that withdrawal side in the next video. The withdrawal side, we're taking money off of our pile of money, so who knows how much we're taking out, but the idea is that we start out with some amount and then we're pulling money out of our account. Maybe we're retired and this is our retirement income that we're taking. And then sometimes, but not always, we're going to end up with 0. So these are the types of scenarios we're going to be working with in the next couple of videos.